Okay, so here we have our conversion instruction, which is TOD and FRD. TOD will convert your binary number into binary coded decimal, and then you have FRD, which will convert from binary coded decimal into binary. Which means in TOD, your source is a binary number, and what you're going to have at your destination is going to be a binary coded decimal. And in FRD, your source is a binary coded decimal, and then you're going to save the equivalent of this binary coded decimal in binary form. Now, these two instructions are very straightforward, they're very simple, and you can easily use them. There is one single problem that you should be careful about them. So in order to understand the problem, I want to discuss about the range of the number that you can get in a fixed size of memory. Let's focus on a block in the memory, which is one word, or in another word, it's 16-bit. I want to know what is the maximum integer number I can get with 16-bit, and what is the maximum number I can get with a binary coded decimal number system. So if I'm focusing on integer number, the maximum integer number I can get is equal to 32,767. Where this number comes from? This number comes from the fact that if I have a 16-bit and I'm focusing on both positive and negative number, then the maximum that I can get, the maximum value that I can describe as an integer number with 16-bit is equal to 2 to the power of 15. So this is where this number comes from. On the other hand, if I want to describe a binary coded decimal with the same size of memory, which is 16-bit, the maximum I can describe is 9,999. Where this number come from? This number comes from the fact that if I have 16-bit and I partition this 16-bit into groups of 4, which I need in order to convert my number into binary coded decimal, then I have 4 partition of 4, and it means that I can describe 4 decimal digit. So consequently, the maximum I can describe is equal to 9,999, which means I have to choose each 4 digit to be maximized, and that's equal to this number. As you can see, the range is totally different when I'm trying to describe the maximum number with the same size of memory as an integer or in binary coded decimal number system. So what can be the problem of this difference? Okay, let me erase this here. So the problem that can happen is related to the difference between the range. So the first one, the integer number, has a longer range. Let's assume that this is the range that you can cover with your integer number. And then this is the range that you can cover with your binary coded decimal number. Okay. Now, what can happen is that if you choose a number in your binary coded decimal system, which has this range, then definitely there is an equivalent in integer as an integer number for it, which can be described in 16-bit. But if you want to choose a binary number which is described with 16-bit, it can have a value which is much more greater than the equivalent in binary coded decimal with more digit. So if you are converting from binary coded decimal into binary, then there would be no problem, because binary coded decimal has a lower range and it can cover less numbers. So with conversion from binary coded decimal to binary, which is FRD, there's no problem. So this is a very simple and a straightforward instruction. So it doesn't need you to be careful about what is the number you are entering as your source. So whatever number you enter as your binary coded decimal has an equivalent binary number, which can be described with 16-bit or the same size of memory as your BCD. But on the other instruction, we might have the problem. So if you choose your binary number in this range, then there is no problem. You're going to receive its equivalent binary coded decimal. But if you choose your number from out of the range, so somewhere here, let's assume, for example, let's assume that you're choosing 15,000. Then in order to describe its equivalent binary coded decimal, you need to have more than 16-bit. Obviously, you have 5 digits, so it means that you need 20-bit, and you don't have this much of memory to describe. So that's the problem. So when you are working with TOD, you should be very careful that your binary number is in the range of your binary coded decimal number. So in that scenario, if you choose your number out of range, then what will happen is that you're going to receive a flag, and the flag happens by setting an overflow bit within your program. So this particular instruction you need to be a little bit more careful if you are working with this one, because you might receive a red flag if you choose a binary 16-bit binary number which has a decimal value greater than 9,999.